If you're the type who doesn't want to just memorize formulas, it's not too hard to make sense of something like the logarithm base 2 of 8 is 3. One way, 8 blocks, divide by 2. 3 times, 1 block left. Or the logarithm base 2 of 4 is 2. 4 blocks, divide by 2. Twice, 1 block left. But what about 3? Blocks aren't all that insightful. A calculator can give you the right answer, but how do you think about that? Well, logarithms with blocks works some of the time, but switching to a number line will make logarithms sublime. 8. Divide by 2. You're here. Divide by 2. Here. Divide by 2. And you've got to 1. The logarithm base 2 of 8 is 3, because 3 divisions by 2 to get to 1. 4. Divide by 2 twice to get to 1. But 3. Divide by 2, you haven't gone far enough. You're trying to get to 1, and you're still above 1. But if you divide by 2 twice, that's too far. You're at 0.75, which is less than 1. The goal is to get to 1, not to go past it. My point. What's needed is a way to move a smaller amount. A smaller jump. But a jump is a division by 2. So say half a jump is half a division by 2? You can't do half a division by 2. Or can you? How to divide a number by 2. Take the number, divide it by 2. How to divide a number by 2. Take the number, divide it by 1.41421. Divide it by 1.41421 again. That's the number divided by 2. And you can do half of that. Half a division by 2 is a division by 1.41421. I'll explain the number 1.41421 in more detail later. To recap, the logarithm base 2 is how many times you need to divide a number by 2 to get to 1. Divide by 2. This rule doesn't do enough, so we need a new rule, a smaller jump. Half a division by 2. Divide by 1.41421, and instead of adding 1, add 1/2. When introducing new rules, it's good practice to check that they don't conflict with the old rules. 8. Divide by 2 3 times. Or divide by 1.41421 6 times. These rules do not conflict. You can think of dividing by 1.41421 as half a division by 2, because if you divide by 1.41421 twice, that does the same thing as dividing by 2. With only divisions by 2, 1 division by 2, not far enough. The goal is to get to 1, so you need more. So the logarithm base 2 of 3 is greater than 1. But 2 divisions by 2 is too far. So the logarithm base 2 of 3 is less than 2. With only divisions by 2, you can say that the logarithm base 2 of 3 is between 1 and 2. With half divisions by 2, a division and a half isn't enough. It's still less than 2. Between 1.5 and 2. Let me show you another example. The logarithm base 2 of 4.6. With only divisions by 2, it's greater than 2, less than 3. With half divisions, it's greater than 2, but less than 2.5, so between 2 and 2.5. My point, with whole divisions by 2, you can find logarithms to whole digits. With half divisions by 2, you can find logarithms to half digits. But if we wanted tenths of digits, to be able to say something like the logarithm base 2 of 4.6 is between 2.2 and 2.3, we'd need tenths of a division by 2. So the question is, what is a tenth of a division by 2? The answer, a division by 1.07177. Back to the logarithm base 2 of 3. The logarithm base 2 of 3 is 1.584. Why? Well, the 1 here, because you can do a whole division by 2. The 5, because you can do a tenth of a division by 2 5 times, but you can't do a sixth. Another example. The logarithm base 2 of 7 is 2.807. The 2 whole jumps. The 0.8, 8 tenths of a jump is not quite enough to get to 1. Whole divisions by 2 and tenths of a division by 2 give you the whole part of the number and the number in the tenths place. But if we wanted the hundredths and the thousandths place, well, a hundredth of a division by 2 is a division by 1.00695, and a thousandth of a division by 2 is a division by 1.00069. So, the logarithm base 2 of 3 is 1.584... Because divide by 2, that's the 1. A tenth of a division by 2, 5 times. A hundredth of a division by 2, 8 times. And a thousandth of a division by 2, 4 times. A bunch of smaller and smaller jumps representing more and more digits. This could keep going, but I'm going to stop here. I'll mention that the numbers 1.07177, 1.00695, etc., they're like pi, they go on forever. And the logarithms of numbers also often go on forever. It's all approximations. Also, please be kind to yourself if this doesn't make much sense at first. It's quite complicated. Thank you for watching my educational video. I hope you learned something. Where did the mystery numbers come from? What? Where did these mystery numbers come from? Let's start with the 1.41421. You can find this number with guess and check. Start with, say, 1.5. 2 divided by 1.5 divided by 1.5 is less than 1, so 1.5 is too big. 1.4, that's too small. 1.42, too big. 1.41, too small. There's a better way. I'll call the mystery number x. 2 divided by x again is 1. Quick algebra, it's the square root of 2. So the numbers 2, the 10th root of 2, the 100th root of 2, and the 1000th root of 2. The logarithm base 2. How many times you have to divide by 2? By the 10th root of 2. By the 100th root of 2. By the 1000th root of 2. Thank you for watching my educational video. I hope you learned something.